All right, and welcome to part 3 of our series. This time we are going to look at programming our Arduino Uno using the Rust programming language. Rust is a fairly new kid on the block as far as programming languages go, and we'll get started. In order to run Rust on Windows or anything else, you will need to install RustUp. RustUp is the installer for system programming language Rust. You can find it at rustup.rs. There's a Windows installer. You can get it for Linux by using curl. But go to rustup.rs and you can get RustUp installed. Once RustUp is installed, we will need a PowerShell to do the rest of this. And we're going to need to install a number of things in order to get started as far as our tool set goes. In order to build Rust using the hardware abstraction layer for the Arduino, we need to install the nightly toolchain. So we can do that just by typing in rustup toolchain install nightly. I've already done this, but I'm going to do it again just because it should update my toolchain to the latest version here. Alright, once we've got that nightly toolchain installed, the next step is to install Scoop. And the first step of installing Scoop is we need to basically change the execution policy so that we can install a remotely signed thing as our current user. So we can use the set execution policy remote sign -scope to our current user. We'll go ahead and do that. I've already done it. If you haven't done it, you'll see a bunch of stuff shown. And then after that, we got to install Scoop. I'm not going to actually execute this command, but it would be irm get.scoop.sh and pipe that to IEX, and that will actually install Scoop. Once Scoop is installed, I've already installed it. You could do Scoop install avr-gcc, and then once that's done, you need to install avr-dude. So those are the commands we need to install with Scoop. So the management system for Rust is called Cargo, and we need to install a couple more things before we can actually get started. That would be a cargo install cargo-generate. We need to install that. And then the other thing we need to install is a program called ravedude, and that is will be used by the cargo system to actually call avr-dude in order to program our chip. That's pretty much it for the installs. We are now ready to basically generate a shell project. And we do that by saying cargo generate, and there's a template that we can use, which will basically do our Blinky for us. It's at github.com rahix, and it's the avr-hal-template.git. So basically we can generate a project, and we're going to do this from a get template, and that is the address of where that get template exists. When we run this, it's going to ask us for a project name. Notice I'm already in my Arduino Hello World Rust folder, so I'm just going to call this project Hello World. And the next thing it's going to do is say what board are we using. Well, we can select all the different boards here, but we are actually using an Arduino Uno, so that's the one we'll select. And then if we look, we now have a hello world. And in here, we've got a Rust project all set up for us. We can look at our source file. There's our main.rs. And let me bring this over to the right window, and let's see if we can blow up the font a little bit. Let's do Consolus and 18 point. That should make things a little bit more readable. Let's expand this out a little bit. So this is basically our Blinky code already written for us. So let's just kind of go through this. This first line here, the pound exclamation bracket no underscore standard bracket. What that's telling the Rust compiler is that we're not compiling against a standard library, right? We don't have an operating system. This is running on an embedded architecture. So we're not compiling to a standard C library or standard library, and we're not having like a regular main entry point. So that's what these two lines are telling us. And we need those because we are on an embedded platform, we're cross-compiling and all of that good stuff. The next thing here, this is defining what to do on a panic. This next piece here is pretty important. This is telling the Arduino how that this is our entry function. Now this function, it's called main in the template. It could be called foo, it could be called do something, it could be called whatever. But what this is doing is registering this as our entry function into our Arduino program. All right, now these next couple of lines, let's get rid of these comments. All right, so here's our function. Basically, we're bringing in from the Arduino how the peripherals. We're going to take those and then unwrap them and store them into a variable called DP. That's going to give us access to all the peripherals that the how provides. And the other thing we need to do is get access to the pins because we're going to be blinking the LED, right? So we do that by the Arduino how pins. We pass it the peripherals so we can access the pins. And then we create a new variable called pins. Excuse me. Now this next line here, this is like what we did in our sketch when we did the setup, when we set the pin to an output. We did the same thing in the C. Basically, we're creating a variable called LED. We're making this one mutable, which means it can be changed. And basically, we're saying that our pin, digital 13, we're going to make that into an output. So it's going to set that pin to be an output. Then we've got our main loop here, which is going to loop forever. And then all we're going to do is toggle the state. So if it was off, we're going to turn it on. If it was on, we're going to turn it off. And then we've got our delay function. And right now, it looks like by default, we're going to delay for 1,000 milliseconds. I'm just going to change this to be 250 just for fun. So that is the Blinky portion. Now we just kind of have to write the hello world portion of our stuff. So right up here, we're going to add another variable. We'll say let mute because we want it to be mutable. We'll just call it serial equal our Arduino how. And this is what we're getting out of the Arduino how is the default serial peripheral. And we got to pass it our DP, our peripherals. And we got to pass it our pins. And then the baud rate we want. So let's just say 57.6. So that's setting up our serial UART for use. And then we're just going to go here right under our toggle. And we're going to say UFMT, which is a format. We're going to do an unsigned format. So we're going to do a UW or UWrite LN. If I could type today, would help. And we got to pass in our serial and let it know that it is mutable. So we're sending a reference to our serial port. And then what do we want to say? We want to say hello Rust world. And then we need to unwrap that command so it actually executes. And that's basically it. If I go ahead and save this right now, that is basically our Rust program. We didn't really have to write a whole bunch of code. We just had to instantiate our serial object and then use it to print. Now the next step, obviously, we need to build this. So we are in our directory. I'm not in Linux. We need to build this. So I'm going to say cargo build. And it's going to go ahead and build our system. I'm going to pop this up over here. And we're going to pop our Arduino right there so we can see both of them. And of course I misspelled unwrap. So let's save that and let's rerun our cargo build here. And this time we finished. Now in order to run this, we just say cargo run. This will download our code to the Arduino. You can notice our LED is now blinking faster, and we are every 250 milliseconds spitting out hello Rust world and blinking, changing the state of our LED. So with that, that pretty much concludes this introductory series on the Arduino. So we've done hello world basically using Sketch. In the first video, we did it using C programming in the second video, and then we just demonstrated using Rust in this latest video. If you like things, go ahead and hit that subscribe button, and thank you for watching my videos.